So hello guys, with the name of God Ram Ram. Today we are going to solve a very difficult problem which was asked in media.net online assessment. Okay. The prerequisites for this problem are dynamic programming and bit manipulation. Okay. Even if you don't know these topics, I will try to give you some basic idea. Okay. So guys, always remember that in all the popular DSA sheets you do, in all the DSA courses you go to, always remember that the people are only training you for popular DSA standard problems, which will only help you in the interview. It will not help you crack the online assessment. For the preparation of online assessment, you need to practice the problems of these different topics which are based on unseen hard DSA problems. I don't see anyone training their students for unseen hard DSA problems, OA problems, and contest problems. Because of that, the student is never able to crack OA and they are always in a dilemma on how to crack an OA. So I have made a 800-hour course and curriculum, okay, structured course for cracking the online assessment of top tech companies, be it Amazon, be it Coordination, Media.net, Google, etc., and also the medium level companies, etc. So apart from that, we give daily live training for hard DSA and OA problems for beginner till advanced level for daily 8 months, Monday to Sunday. So Monday to Friday, we give the training, and Saturday, Sunday, we do one-to-one mentoring. So our results of selections are very high. Like just in this July month, 58 students of mine cracked the 10 plus LP offer off campus and on campus. Okay, despite the recession going on, and since January or last December, 548 students of mine have cracked 10 plus LP offers. Okay, if you go and check like this LinkedIn post for the July month, our top five selections are these. So we will like to congratulate them. Okay, my student Rashi Bhave cracked the Microsoft off-campus offer as a 2023 grad. My student Dev Sharma cracked Zomato off-campus. My student Aniruddha cracked the SD senior SD role, or you can say SD2 at Visa. My student Akhil cracked the senior SD, or you can say SD2 at BNY Mellon. My student Sheel Agarwal cracked the Samsung as the 2023 graduate. So, and apart from that, more 58 students cracked 10 plus LP offers. Okay, so we give live training for DSA for OA, plus interview, plus full stack development, plus LinkedIn training, plus resume training, plus off campus training. And we personally help the interview a person to prepare for the interview, their mock interviews, and their communication skills we try to improve. Apart from that, we personally give one-to-one mentoring live each Saturday Sunday to take care and keep each student on track. Apart from that, guys, because we are putting so many personal efforts on each student personally, each student ends up getting selected. Okay, unless there's some personal issue where they were not able to focus about, some people get ill for 3 to 4 months. Yeah, then in that case it can happen that the person might not crack, but generally any student who focuses and works hard with us and attends Saturday Sunday live mentoring, Monday to Friday live training, always ends up getting selected. Apart from that, guys, we also do one more thing, which is we personally help before each person's interview and online assessment round. So we make sure that they crack the offers. Okay, so if you want to enroll in our training, you can check the link in the description below. Okay, and if you are my YouTube subscriber, okay, so you should be able to solve these hard unseen dynamic programming problems. Even if you are not my student, you are just my YouTube subscriber, you can get lots of benefit. You will be able to crack the easy, medium, dynamic programming problems which are unseen and hard if you go to the playlist and check out this dynamic programming playlist. Like just go through as many videos as possible in this playlist and you will be ready to solve the easy, medium, dynamic programming OA problems. Okay, and similarly I have the playlist on the bit manipulation also, like this, you can check here. Okay, you should watch these before generally going through the explanation of this video, because this video is going to have the explanation to the media.net OA. Media.net and Coordination as the hardest OA in all of India for their SD and freshers role, okay, for the software development engineer. So let's see how can we solve the problems. And these are my credentials, some of them. Okay, you guys can check. Before going to the problem, guys, let's go through a little bit of prerequisites. Okay. So guys, these are the decimal numbers you might be knowing if you're a CS student: 0, 1, 2, 3, 4, 5. If you convert the decimal number to binary numbers, they will look like this. See, 000, 001, 010, like this, like this, like this. Guys, there is a function called as bit count function. Bit count function will tell you how many ones are there in the binary representation of the decimal number. So in zero, the binary representation is 000. There is no one, so answer will be 0. How many ones are there in the binary representation of one? There is a single one. So the bit count of one will be one. What will be the bit count of two? if you convert the 2 to binary, you will see that there is only one 1. So the bit count of 2 is 1. What will be the bit count of 3? 2, because there are two ones in the binary representation of 3. Similarly, bit count of 4 will be 1 and bit count of 5 will be 2, because 5 looks like this 101, there are two ones. Okay. So, this much knowledge you should have. Apart from that, what is XOR? So, guys, whenever you try to do XOR of two binary numbers, if they both are different, like 1 0 0, answer will always be 1. Zeros or 1, answer will be 1. If both the numbers are same, zeros or 0, then the answer will be 0. Ones or 1, answer will be 0. Always remember, if you're trying to do the XOR of two binary numbers, okay, the same will be later be applied to the decimal numbers. But if you're trying to do the XOR of binary numbers, both of them are different. So it can be 1 and 0 only. So 1 XOR 0 will be 1, zeros or 1 will be 1. Okay. But if both the numbers are same, like zeros or 0, answer will be 0. Both the numbers are same, 1 or 1, answer will be 0. This much basic knowledge you should have. Okay. Now we can go towards the problem. Okay. So let's see what the problem is saying. It was asked like a few days ago only, or you can say a week ago. Most probably, I think it was 5 to 8 days ago. So, guys, the name of the problem is XOR subsequences. You are given an array A. You have to like create an array B, which is the subsequence of A. An array B is called valid if it satisfies both the condition, guys. Both the conditions. Which are those conditions? Let's see. B of I should be less than B of I plus 1 for all the indices, okay, except the first guy, obviously. Bit count of the XOR of all the I guys should be less than equal to the bit count of B of I plus 1 guy, okay. And let X be the bitwise XOR of all the elements in the valid array B. So whichever are the valid subsequences, whatever XOR value their subsequence can generate, you have to tell how many different XOR values can be there. The like the size of the array A can be 10 raised to 5 and all the elements can reach till 100 only. So this is a very important observation. Why in this problem are we given such a less number 100? Okay, like why the array in like the each element can only go from 1 to 100, not more than that. But the size of the array can be as long as 10 raised to 5. Okay, so let's try to first make the understanding of the question clear, guys. Let's try to make the understanding of the question clear. Okay, so, understanding, just let me in the Jamboard write our main thing. You always, guys, whatever you do in your life, start it with the name of God, Ram Ram. Then no one will be able to stop you from going to your path. Okay, even God will help you. So, guys, let's go to the through the understanding of the problem. Okay, guys, this problem is super hard, but I will try my best that even a beginner can understand. What is the understanding of the problem? You are given an array. You are given an array. You are given array A. You are given A. Okay, this is your array. Okay, you are given an array. You're given an array. You have to find all the valid subsequences. Guys, you have to find all the valid subsequences from the array A. Okay, you have to find all the valid subsequences from the array A, such that such that they are sorted. First condition is that they should be sorted, right? Such that they are sorted. Second, uh for any index I, for any index I, the bit count, see, I taught you the bit count. The bit count of b1 XOR b2 XOR till bi should be less than equal to the bit count bit count of the ith guy. Okay, so this should be followed for all the guys in the index, all the guys in the our selected valid subsequence. Once you have all the valid subsequences, once when you get when you get all the valid subsequences, when you get, guys, all the valid subsequences, then what can you do? Check the XOR, check their XOR. Once you know their XOR, task is to calculate, task is to calculate how many different XOR can come, That's it, guys, that's it. So, guys, let me take an example, okay? So let's say our array is 1, 2, 3. So how will we check which subsequences of these are correct? Let's generate all the subsequences. One subsequence is 1, another is 2, another is 3, another is 1 comma 2, another is 1 comma 3, and another is 1 comma 2 comma 3. Let's check if they are valid or not, guys, if they are valid or not. So 1 valid, is 1 valid? Yes, it is valid because it is a single number. Is 2 valid? Yes, it is valid. Is 3 valid? Yes, it is valid. Now they are asking, now let tell me, is 1 comma 2 valid? Let's see it is following all the conditions or not. First of all the numbers should be sorted strictly greater, okay, sorted in strictly ascending manner, okay, sorted in strictly ascending, okay, equal numbers are also not allowed, strictly ascending. Okay guys, all of them should be strictly ascending, okay, all of them should be strictly ascending. So yes, first condition is satisfied, 1 is less than 2. Is the second condition satisfied? What is the second condition? Bit count of 1 should be less than equal to bit count of 2. So what is bit count of 1? What is bit count of 1? If you check in the media.net away, bit count of 1 is what? 1. And bit count of 2 is what? 1. So yeah, bit count of 1 is less than equal to bit count of 2. 1 is less than equal to 1. Yeah, correct. So bit count of 1 is also 1 and bit count of 2 is also 1. So this less than equal to condition is satisfying because equal is also there, right? So yeah, 1 comma 2 is a valid subsequence. Now, is 1 comma 3 a valid subsequence? Let's check. First thing, it should be in a sorted manner. Yeah, 1 is less than, yeah, 1 is less than 3. Second, strictly sorted. Yeah. Is the bit count of 1, there is no other elements, we will not do any XOR, is less than equal to the bit count of 3. Guys, this is very interesting. I'm enjoying it really. What is the bit count of 1? The bit count of 1 is 1. Bit count of 3 is 2. Yes, bit count of 1 is less than equal to bit count of 3. Correct. 1 comma 3 is also perfect. Valid subsequence. Valid. Let's check. Is 2 comma 3 valid or not? Now it will be interesting. Is 2 comma 3 valid? Is it valid? First, I know it might be yes, but let's check. Let's first check, guys. Never celebrate before the success is confirmed. Learned it from many past experiences of me and my students. So, yeah, first thing is correct. 2 is less than 3. Is the second thing correct? OA problems are very easy. If you can deeply analyze and you have the right knowledge. The bit count of 2 is less than equal to bit count of 3. Yes, it is true. If you go and check, if you go and check, uh, bit count of 2 is 1 and bit count of 3 is 2. So yeah, 1 is less than equal to 2. So guys, now let's check for is this valid? 1, 2, 3. Is 1, 2, 3 valid? Yes, the first condition is correct. First condition is correct, which is 1 less than 2 less than 3. Now in the second condition, guys, you will have to check the two cases, okay? For each index I, you will have to check, okay? First is that the bit count of 1 should bit count, okay, wait. Bit count of 1 XOR 2, okay? Bit count of, okay. There are multiple elements here, no? No one explains such hard problems. It's my job to explain such hard problems, my goodness. Anyways, guys, the first thing is that they told that for each index I, the bit count thing should be satisfied. So first thing is that the bit count of 1 should be less than equal to bit count of 2. The second thing is that the bit count of 1s or 2. You checked for this much part, now you have to check for this part also. For this particular index, the whatever is the XOR of the first I indices, say this is I plus 1 and this is I and this is I minus 1. So it was clearly written, this is I minus 1, this is I and this is I plus 1. So I plus 1 is what? 3. So bit of 3 should be less than equal to bit of I minus 1 XOR I. So 1 XOR 2. So whatever is 1 XOR 2, 1 XOR 2 will come out as 3 only. So bit of 3 should be less than equal to bit of 3. Yeah, this is valid. And bit of 1 should be less than equal to bit of 2. This is also valid. All these are valid. Hence, 1 comma 2 comma 3 is also valid. See, it was clearly written here that for each index I, b1s or bi's or b2s or b3s or bi minus 1s or b of I should be less than equal to b of I plus 1. So मैं क्या कर रहा हूँ कि मैं हर I plus 1 के लिए चेक कर रहा हूँ, वैलिड तो है ना, तब जाके तो वैलिड होगा. ठीक है, गुड. So guys, in our lucky case, all the subsequences are valid. So the question is find the XOR of all the subsequences and tell me how many different XOR values are possible. That's what our question is all about. So now guys, now, so which are the valid subsequences? 1 is valid, 2 is valid, 3 is valid, 1 comma 2 is valid, 1 comma 1 comma 3 is valid, okay. 2 comma 3 is valid, 1 comma 2 comma 3 is valid. What is the XOR of this? XOR of this is 0. What is the XOR of this? So 2 looks like this, right? 3 looks like this. So 1 0. So XOR of this is 1. 1 is a single element, so XOR is 1. 2 is 2, single element. Single element you cannot do XOR with anything. 3 3. 1 XOR 2. So 1 looks like this, 2 looks like this. So 1 XOR 2 will be 3. So 1 XOR 2 is 3. What is 1 XOR 3? So 1 looks like this. I think it will be 2. So 1 1 0 1 0 1 1. So it will be 2. Guys, these are the different values which were possible. Either the XOR of the valid sequence can be 1, it can be 2, it can be 3, it can be 3, it can be 2, it can be 0, it can be 1. Which are the different values which are coming? 0 is coming, 1 is coming, 2 is coming, 3 is coming. So if you take all the valid subsequences and you check which are the different XORs coming, these can come, this can come, this can come, this can come for all the valid subsequences. So answer will be 4, because 0 1 2 3, there are 4 different values which can come. See, 0 came here, and if someone is coming repeated time, you don't count it repeated time, you count it for one time only. 0 is coming, 1 is coming, 2 is coming, 3 is coming, and the output for this question will be 4. Okay, if the case was 3 1 2 3, this was a simple case. There can be some cases where there are multiple sequences which are not valid, then you will not consider their XOR. For example, if you consider this case, this is not valid. Why? If 1 was there, because 1 less than 2 less than 3 less than 1, this is not being satisfied, and in some cases the bit count condition will not be satisfied, that less than equal to 1. So we have to be very perspicacious and careful. So guys, how do we solve this problem? Guys, in my written DP tutorials and in my dynamic programming videos, I have always taught, no matter how much of a noob or a beginner you are, you always solve the DP problems like this. First is, you create an empty array DP. Okay, you create an empty array. Guys, love you all, love you all, you just love me back. So guys, you always, this is my strategy of solving DP problems. You go to all the popular standard tutorials, popular DSA sheets, no one will teach you like this, okay? I'm going to teach you in a very nice way. I will not even involve the memorization and recursion part. Let's go through it super easy. Guys, always make an empty DP array of size n. I know you don't know anything, just make an empty DP array of size n. The states, the recurrence formula, we'll discuss later. First, no matter who you are, try to make an empty, like when you develop you will automatically know what to do, but for now just make an empty DP array of size n. Okay, done, good, nice. Now what will you do? Now try to define the meaning of DP of I. Generally DP of I means the best answer to the question if you are considering your array from index 1 to I. So try to define it nicely. Once you're done with the definition, try to find DP1, DP2, DP of 3, DP of 4 by observation. Okay, try to find it. Once you're done doing this, once you're done doing this, the step number 4 should be to make a recurrence formula. It should be to make a recurrence formula. First, you make the empty DP array. Try to clear the meaning of DP of I in your head. So, like there were some problems which are very highly rated. Okay, I was trying to solve them on my own, and I was mostly correct there. Okay, I realized that the main thing to do was to correctly define the DP of I according to the requirements of the problem. So first you define the meaning of DP of I, then you try to calculate DP1, DP2, DP3. Once you have this value, you try to calculate the formula of DP of I in terms of the previous DP value, like DPI minus 1, 2, 3. Once this is done, you will get a formula for DP of I, and then put this formula in a for loop and calculate all the values from dp1 till dpn. And dpn, in most cases, it is your final answer depending on the requirement of the question. Dpn will give you the best answer for the question if the size of the array is from 1 to n. So guys, in our question also we are having an array, right, from 1 to 10 raised to 5. So what will be the meaning of dp in our case? Dp of I should be we want what we want, We want to know how many valid subsequences are there such that their XOR is coming something. Their XOR is coming something. Okay, okay, okay. So guys, DP of I should be what? Should be somehow representing the subsequence which you can pick from index I equal to 1 to index I equal to n, such that their XOR is j, such that their XOR is j. The XOR track, you will have to keep the track now. What is the XOR coming of that subsequence? Such that the XOR is j and the last value is k. Guys, you will also have to keep the track of last value. You might ask why. सी गाइस, सपोज आपने सबसीक्वेंस एक उठा लिया 1,2, ठीक है। 1,2 आपने उठाया है, कहाँ से कहाँ तक उठाया है मैं आपको बता देता हूँ। योर एरे वॉज फ्रॉम इंडेक्स 1 till 100, ओके। नाउ से यू randomly pick up a subsequence 1,2 from here. Now if you are at the index 101, here 3 is written, so you can join the 3 only with the guy whose last element is less than 3. So that's why we need to keep track of two things. What is the XOR of this subsequence, which is XOR is j, and what is the last element of the subsequence, which is k. K is 2 in this case, and XOR is 1, XOR 2, 3. Okay, so you need to keep the track of the XOR and the last element, because the last element will help you know if you can join it with 3, and the XOR of all these elements, if you have, तो तुम एक झटके में check कर पाओगे कि bit count of this XOR is less than equal to bit count of the current number or not. So taking the track of XOR and last number is very important. Nice, great. Okay, and like, to understand these things in depth, you should watch all my dynamic programming videos. Either you should enroll to become ultra strong, or you should at least watch my YouTube videos. Okay. So guys, DP of I should somehow represent. Now learn how to make those states. No YouTuber or person will teach you how to make the states. They will directly tell you the states. I will tell you. Always remember, we will reach the solution organically. That's what the main thing about Kumar ke mentoring and training in Desi Queen. We have this Desi Queen website which has 5 lakh daily visitors. Okay, so all this has come out because of the hard work of me and my students. So now guys, always remember, necessity is the mother of invention. Similarly, the DP state and the formula and the recurrence is the, like, all this necessity was the mother of invention, right? Similarly, the requirement of the question is the mother of the DP state and the DP recurrence formula you need to make. Okay, let's call it as DP formula. So, guys, you can feel it, right? That somehow DP of I should tell you that you pick up a sequence from index 1 to n such that the XOR is j and the last value is k. But guys, we are not able to represent j and k. But we are not able to represent the j and k. So let's create state for them. So let's create state for them. So guys, let's create state for them. The state should be DPIJK. Guys, DPIJK. Now this is very easy, guys. Multi-dimensional DP programming, dynamic programming. What will be the meaning of DPIJK? DPIJK will tell you, DPIJK true means there is a subsequence, there is a subsequence. Okay guys, there is a subsequence from index I to, from index I to 1 to n, 1 to n, index I to 1 to n. From 1 to n, guys, there is a subsequence such that its XOR is, guys, such that its XOR is j, and last element is k. That's it, guys. That's it. Now your job is done. Now you're ultra relaxed. For example, say my array looks like this. Okay, this is index 1, index 2, index 3, index 4. Let's take one based indexing. Now if someone comes and tells you, dp of 4, dp of 4 and 0 3. Okay, what is the meaning of this? Can anyone tell me in the chat? It's very easy. If you think carefully in your life, it's very easy. This simply means is there any subsequence from index 1 to index 4? DP of 4 means is there any subsequence from index 1 to 4 such that their XOR is 0, such that the XOR is 0 and the last element is 3, such that the XOR is 0 and the last element is 3? Yes, there is. Which is that subsequence? It is 1 comma 2 comma 3. It is coming inside 1 to 4. Yes, this is now checked correct. Is the XOR 0? Yes, 1 XOR 2 XOR 3 is 0. This is also correct. Is the last element 3? Yes, correct. So DP403 is true. It means that from index 1 to 4, this is my passion, guys. I love this thing. Teaching and doing hard DSA problems and seeing and making my students successful. That gives me the highest kind of joy. We have daily 10 plus LBA selections in our program. This is happening because of me and my student unlimited hard work and perspicacity. So guys, this 1 2 3 4 we have, right? The thing is, DP403 is true. If it is true, it means that from 1 to 4 there is a subsequence such that the XOR is coming as 0 and the last element is 3. Yes, 1 2 3 it is coming from 1 to 4, its XOR is 0 and the last element is 3. Yes, so it is true. So I hope you now understood that DPIJ true means there is a subsequence from index 1 to n such that its XOR is j and last element is k. Good, nice. Now, DP. If this comes as false, guys, if this comes as false, means there is no sequence, there is no subsequence such that from index to 1 to n, 1 to n, from such that from index 1 to n, its XOR is j and last element is k. For example, if I come and tell you that ha ha ha, like for this array only, let's take this array. Okay, let's take the indexing 1 2 3 4, dp of 4 of 50 of 2. Is there any guy from index 1 to 4 such that the XOR is coming as 50 and the last element is 2? If the last element is 2, you can only pick this 2. This 2 can never give the XOR as 50, so this will be false. Okay, or you could say, is there any guy from first? Okay, you don't need to do anything of that. I hope you understood till now what is true, what is false. Okay, like you could even reverse the values. So I just cut it for the fun, but you guys understood now. It true means that this thing is happening, false means this is not happening. For example, DP4 of 50 of 2 is false. Why? Because from index 1 to 4 there is no guy whose last element is 2 and XOR is 50. If last element is 2, then you cannot take any element after 2. So you can only take one subsequence, which is 2. So is it XOR coming as 50? No. 2 is a single element. It's XOR of 2 with, you cannot do with anyone. So it will remain 2 only. And it is not 50, so that's false. Okay, so this much is done. So guys, now the another trick is, once you are able to, like we taught in my DP course, once you're able to calculate for the small DP values like DP123, we are able to analyze this, right, for DP123. Okay, now let's move to the direct trick. Okay, the direct trick says try to analyze, like there is one more trick which I taught in the course and did not write here. Try to analyze a very large array and try to make the recurrence formula. So this I am assuming that the people watching these videos are already advanced kind of people. Okay, so guys, if you are at index I, okay, you're at index I. Okay, this is I minus 1, this is I minus 2, this is I minus 1, this guy inside this is 1, this is 2, this is 3. Okay, guys, can you imagine what will be the value, what will be the value for dp I j k? What will be the formula for this? Let's try to make the formula. Let's say our k was 3. What will be the formula? It means, is there a subsequence, is there a subsequence from index 1 to index I such that such that the XOR is coming as j, such that the XOR is coming as j, and the last index is 3, and the last index is 3. Okay, such that the XOR is coming as j and the last index is 3. Guys, you know what you can do? You have two options. You either make the current element as the last element, or you ignore the current index. Okay, so for dpijk, for dpij3, you only have two options. Okay, you only have two options. Okay, okay, so this means that is there a guy from index 1 to I such that the XOR is coming as j, it is a valid subsequence, and the last element is 3. So either you consider I index as the last element, or you don't consider I element as the last index. Don't consider I element as last. So guys, what will happen if you don't consider I as last? What will be there are two options. Option 1, consider I as last. Option 2, don't consider I as last. Then the answer will be simple, yaar. Will be simple. Answer will be very simple. This was your index 1. Okay, you came till index I. Here it is I minus 1, I minus 2, like this. Okay, it is going like this. So if you are not considering the last guy, then you can clearly say if you can clearly say if dp of I minus 1 j3, if this is true, if this is true, it means that if there is a subsequence from index 1 to I minus 1 such that the XOR is coming as j and the last index is 3, then the same thing will be valid for dpij3. So basically I'm trying to say this formula always holds true. dpij3, this is nothing but what, guys? This is nothing but what? This is dp of I minus 1 j3. इसमें क्या बोल रहा है? क्या 1 से लेके आई इंडेक्स तक ऐसा कोई भी सबसीक्वेंस है जिसका जॉर्ड जे आ रहा है और लास्ट में 3 है? तो इसका सिंपल आंसर क्या है? करंट वाले को अगर मैं निकाल दूं तो क्या 1 से आई माइनस 1 में कोई आ रहा है क्या जिसका जॉर्ड जे है और लास्ट 3 है? अगर ये हाँ है तो ये भी हाँ होगा, ये ना है तो ये भी ना होगा. दिस विल हैपन इफ यू आर नॉट कंसिडरिंग द लास्ट एलिमेंट एज आई. लास्ट एलिमेंट को मैंने आई को इग्नोर कर दिया. अब मैं अगर आई को कंसिडर करूंगा तो क्या होगा? दैट इज इंपॉर्टेंट. फॉर एग्जाम्पल, say at this index I, my current guy is 3. Okay, this is index 1, this is I minus 1, and all the guys are going behind like this. Okay, so this is the stuff from 1 to I minus 1, and this is your current guy. Guys, what if you try to make this only your last element? Then what will happen? What will be dpij3 if you are considering this as the last element? So guys, you want the XOR as j, right? So let's consider the XOR of the numbers. The subsequence which you picked from 1 to I minus 1 is g. Okay, and this value is 3. So if you do the XOR of g and 3, g XOR 3, this will be j, right? बिकॉज ध्यान से देखो, आपको 1 से आई में एक वैलिड सबसीक्वेंस पिक करना है जिसका जॉर जे आता हो. तो अगर आपका लास्ट एलिमेंट ही 3 है तो कंबाइन कैसे करेंगे? समझो 1 से आई माइनस 1, वॉट एवर यूर पिकिंग फ्रॉम 1 टू आई माइनस 1, इट जॉर इज जी, एंड द लास्ट एलिमेंट नाउ यूर फिक्स दैट इट शुड बी आई ओनली. सो जी जॉर 3 शुड बी इक्वल टू जे, right? G XOR 3 should be equal to j. So what will be the value of g? 3 you will put on the right hand side, it will become 3 XOR j. So guys, it is so simple. If there is a subsequence from index 1 to I minus 1 such that its XOR is coming as G, its XOR is coming as G, its XOR is coming as G, and the last element is less than 3. If this is the case, then yes, dpij will also be true. There were two options. Okay, there were simply two options. One option was, always remember, DPIJK. Option 1 is what? Option 1 is that you, option 1 is option to not include the last element as I. So ith element will not be your last element. Then you just simply ask, is there any other sequence from 1 to I minus 1 whose XOR is J and the last element is K? If true, then true. If false, then false. That's it, guys. Life is very easy. Difficult. Guys, what is the option 2? Option 2 है कि you consider the last guy. You consider the last guy. Let me call it as option 58, not option 2. Option 58 means the other option is option forcefully. Forcefully. Okay, don't write forcefully. Make the last guy as item I. Okay. So guys. First you will need to calculate G. So in this, one thing should be very clear to you guys. Okay. One thing should be very clear to you. Okay, so whatever is the XOR of all the numbers from 1 to I minus 1 means the valid subsequence which you're picking from 1 to I minus 1. Let's say it's XOR is G. So G XOR B of I. B of I is the ith element. It should be equal to J, right? It should be equal to J. Hence G will be equal to J XOR B of I. J XOR B of I. If you know even little bit of bit manipulation, you will know that we can take on left and right hand side. So guys, G will be J's or B of I. So the next option will be, if there is a subsequence from index 1 to I minus 1, if there is a subsequence from 1 to I minus 1 such that its XOR is G, because 1 से I minus 1 का तो XOR G होगा ना. Current value को अगर B of I आपने खुसेड़ ही दिया है, if you are putting the current value as B of I, then whatever is there from 1 to I minus 1 XOR B of I, this should be equal to J. So you take this on the right hand side. G का formula क्या आ गया? G is or B of I. If there is a subsequence from 1 to I minus 1 index such that its XOR is G and the last element is less than K, if the last element, because the last element should be less than K ना, क्योंकि उन्होंने clearly बोला था. If the last element becomes less than K, then yes, it will be the correct answer. So answer will be one of the three options: DPI minus 1 G1, or so whichever is giving true from these, you take this DPI minus 1 G2 or DPI minus or DPI minus 1 G2, okay, or DPI minus 1 G3, or like this. You keep on doing, guys. You keep on doing, okay? Or you will do this or till what, guys? Till what? Till what? Let me remove this also. Now you guys are big. You can do this, okay? Not kids. You will keep on doing this dp of I minus 1 gk minus 1. Why? Because the last, see, what do you want, guys? You really want that you pick up a subsequence from 1 to I such that the last element is K. So now I am dividing 1 to I minus 1 part. See, what I am trying to do is I am doing this trick. We want the answer from 1 to I, right? So what am I doing is I am dividing this part 1 to I minus 1, and I am dividing, making this separate. So if I want to accomplish dpijk, it means I need K as my last guy. So this guy will be B of I na, array B, sorry. So this guy will be the last guy. So I want the XOR as J. So say the XOR of the part from 1 to I minus 1 is G. The subsequence which you're picking from 1 to I minus 1 is G. This is B of I. So G XOR B of I will be equal to J, because you want J na. So the formula of G will be B of I XOR J. So now you just need to find the answer to this will be yes, if there is a guy from 1 to I minus 1 such that its XOR is G as I wanted, and its value, the last element should be less than K. मतलब समझो आपका B of I 3 था, तो आप इधर से सिर्फ वही सबसीक्वेंस उठा सकते हो जिनका लास्ट एलिमेंट या तो 1 है या तो 2 है. 3 से छोटा ही होना चाहिए. XOR उसका G आना चाहिए, बट एलिमेंट 3 से छोटा होना चाहिए. सो विल इटरेट फ्रॉम 1 to K minus 1. such that the abhi samjhe last, why was I keeping the track of the last element? Because whatever is the last element, it should be less than the k which we are trying to find the answer for. So that's all it will be, guys. That's all. Now guys, always remember that let's go towards the code part. Okay, let's go towards the C++ code. Now the things are very simple. We have solved the problem. See guys, we take the input of the array. Okay, I declare a bool dp array. Okay, if the first state will tell you which index of the array you are, the second state will tell you which zor you are trying to achieve, the third state will tell you what is the last element. Now it can only be from 1 to 100. That's why also guys, the zor will also be from 1 to 127 only. Okay, this is a basic bit manipulation knowledge you might be having. The thing is that the numbers inside the array are all only from 1 to 100. The number inside the array are only from 1 to 100, 1 to 100, 1 to 100. Okay, the number inside the arrays are only from 1 to 100. Okay, the number inside are only from 1 to 100, like 1, 2, 3. It can be 100. So no matter which subsequence you pick up and which zor you do, the zor result will never cross all the possible bits. So 1 looks like this. Okay, 8 looks like this. Okay, 16, okay, 8 looks like this. 16 looks like there are 4 zeros. Okay, similarly 32, if you go to 32, 32, 1, 2, 3, 4. So uh, let me write, there are 5 zeros, guys. Okay, 1, 2, 3, 4, 5. And similarly, if you do 32 into 2, 64. 64 looks like this, 1, and then there are 6 zeros. Okay, and if you do double 64, 128, it looks like 1 and there are 7 zeros. So I am saying that the zor will never cross this. This is the maximum zor value it can take. 1, 2, 3, 4, 5, 6, 7. This is the maximum zor value it can take. That's why I'm iterating my zor values possible from 1 to 127 only. Like 128 basically. 1 to 128 only. 128 you don't need to consider, but it's nice. So guys, the thing is कि एरे में जितने भी बंदे हैं ना, वो सब इनसे छोटे हैं. वो सब 1 से 100 में आते हैं. तो 1 से 100 मालूम है कैसा दिखता है? Their binary representation starts from here. Okay, either the this is a this guy 1 2 3. Okay, 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. This guy is definitely less than equal to 100. Similarly, you will create many guys here which are less than equal to 100. This guy is 4. This is also less than equal to 100. So whichever subsequence you pick, it will look like this. यहाँ पर कभी 1 आएगा ही नहीं, because whenever you do a XOR, either the output of this will be 1 here or 0 here. So whatever the output is coming, it will come only in this much part. This will be 0 0 0 0 0 only, because the number are from 1 to 100. If the numbers are from 1 to 100, the maximum significant bit can come only till here. Now if you know a little bit of bit manipulation, you will understand that. So this is the maximum value ना, इससे बड़ा तो हो ही नहीं सकता. So that's why my value is only going from 1 to 128. So now guys, you try start iterating from 1. You can see the little base cases details whenever you want. So guys, first you fill all the DP values with false, and only when J is 0, K is 0, you fill it with true. There is a reason for it. You will automatically understand. I leave it up to the reader to understand why did I did that. Guys, I will create a count of I function which will quickly tell me for a number X or number I, how many, what is the bit count of that number. So for example, if someone comes and tells you what is the bit count of 4, there is inbuilt function in C++ Java Python which can tell you. But अगर तुमको देख के समझना तो bit count of 4 क्या आएगा? एक ही 1 है उसके बाइनरी में, bit count of 4 is 1. So like that I'm creating this bit count function. Okay, now guys, the one more base case, dp1 of b of 1 will be true. This means what? If you are only considering the first element and you put the first element of the array, then the XOR will also be the first element, so b of 1, and the last element will also be the first element, b of 1, so that is true. Now guys, you start iterating from 2 till n. The different XOR values you will try to accomplish. For DPIJ will be, J will go from 0 to 128. The last element can be from 1 to 100, so K is going from 1 to 100. Guys, the first thing I told you, if you don't include the last I element as the last element, then DPIJ is DPI minus 1 JK. See, I wrote it clearly here that dp ijk is dp I minus 1 jk. Okay, simple. And
If see guys, I've clearly written here. If you are considering the kth guy as the last guy, then what can you do? First, you calculate the g. G is k is or j. K is nothing but this b of I. B of I is or j. Then you try all possible values. You try all possible values of L such that L less than k, because the last element should be less than k na, to keep it sorted. So if the g is less than equal to 128, and if there is a sequence from 1 to I minus 1 such that its XOR is g and the last element is L, and L is only going from 0 to less than k. So it's, yeah, if this is also true. And one more thing, guys, the bit count of G means XOR of all the values from 1 to I minus 1 should be less than equal to the bit count of the current guy J. J is nothing but what? That the J is this our current value. Okay. So if this is true, we will get our answer, guys. It's just that. Okay, guys. Yeah. Now let me check a few things. Okay, okay, okay. Yeah, let me check. Okay, guys, here we need to make a change. Okay, here we need to make a change in the code, and that change is that the count G is giving us the XOR of the first I minus 1 elements, right? And our bit count of B of I plus 1 should be greater than equal to that. So this should be bit count of B of I, or you can say bit count of K. Okay, so we should replace it with K. Okay, now there was a slight mistake. Now let me fix it. It should be bit count of k. It should be bit count of k. So let's go there. So let me try to fix it, guys, for you. Because we know this fact, then why to do it wrong, right? C plus plus 14. Okay. So if you write like this, 5, 1, 2, 3, 4, 5. Uh, and guys, once all of that is done, all I am doing is I am iterating. I'm iterating dp of n. Now guys, finally answer will be dp of n only. Dp of n, in one go it will tell you, is there a subsequence from 1 to n such that the XOR is vl, and u values you will iterate from 0 to 100, all possible. 0 was not needed anyways. So if you find a guy whose XOR is VL, I update it in the map KK of VL plus plus, and then whatever is the size of the map, that will be my answer. But there is this issue which I felt with, which is not correct. It is that the count of G is giving you the XOR of these elements from 1 to I minus 1, and the current guy should be K. Okay, now this should be K. That's what I feel, that the count of G should be less than equal to count of K. Then our question is, then it's going all right. So let me run it. Let's check. So guys, this was that simple. Okay, now not much difficult. So if count of G is less than equal to count of K, then that's good. Then that's good. Yeah. See, it's coming correct now. So this is the correct solution. Okay. See, while explaining you guys, I found it out. So I will be updating the C++ and Python codes also, guys. Instead of K, you have to write a J there. Okay. Seems like the IDEON has become slow. So let's replace it with the correct solution. We will discuss the time complexity now, guys. So let me replace. I will be replacing the Java and Python codes also. In only one letter we have to replace, but instead of J, we need to write the K. Guys, time complexity is very high. Okay, now. So this will give a TLE, but it will pass few cases and you will get the interview for sure. Because I don't think such hard problem anyone is going to even reach up till this solution. Most of the people. So guys, you can see that your loop is running from 0 to n. This is going from 0 to 100. This is also going from 0 to 100. And this also can go from 0 to 100, L less than k. So 100 into 100 into 100 into n. So n into 10 raised to 6. And this will be very problematic. Okay. And the space complexity, DPIJK, na? DPIJK. N into 100 into 100. So n into 10 raised to 4. This is also very big. So now we will be going towards the optimized solution. Okay, optimized solution. So guys, how can we optimize the DP states? How can we optimize the DP states? Soon we are going to know that. Yeah, see, in this case, I did it perfectly well. Count of B of I. Yeah. So guys, how can we optimize this? This is also very easy, so interesting. You guys are going to love it. Even I love it. So now, guys, currently there is rainy season going on. How to optimize? How to optimize the DP state, guys? This is enlightening. Okay, if you can do DP like this, you are one of the best in India. Always remember that, and you deserve the best in your life. Try to have feelings for the question, not for the girls. Okay, in your early ages. Once you get successful, you can have feelings for them also, and they will reciprocate. So, guys, now let's not go in the wrong direction. How to optimize the DP state? It means you have to reduce the states. See, currently we have three states, guys. If you reduce the state, number of for loops will decrease and the time complexity will decrease. It means you reduce the state to make it efficient. To make it efficient. Make it efficient. We need to keep track of. Keep track of. We need to keep track of XOR and the smallest element. Smallest. We need to guys keep of the last element. Guys, we always need to keep track of the XOR and the last element. This index keeps the track of the XOR and this keeps the track of the last element. But guys, can you see one thing? If you analyze thoroughly, na, see what is happening in our DP state. You are at the particular index I and this is I minus 1, right? Now what am I trying to do? I am separating it out so my job becomes easy, right? Okay, let me take this. I am separating it out so my job becomes easy, right? So guys, writing what to do when I'm sure that this I element will be the last guy. So let me decrease the state. Let me keep only DPIJ. DPIJ will tell you, okay, is there a guy? Is there a guy? Is there a subsequence from 1 to I such that the XOR is J? Such that the XOR is J. Now guys, it is only possible the full XOR should be J. The full XOR should be J. So I am not explaining that again and again. The full XOR should be J. This is B of I, and the XOR of the part from 1 to I minus 1 will be G. So guys, this is only possible if there is subsequence from 1 to I minus 1 whose XOR is G. But one more thing you have to check na, the last element of this subsequence should be less than B of I. So there are only two conditions, guys. DPI of J will be true if, see, I've reduced the state. If dp of I minus 1, dp of I minus 1 G, if there is a subsequence from 1 to I minus 1 such that XOR is G, if this is true, and the smallest element, smallest possible element which could be there for the subsequence, the smallest element is less than B of I. Guys, this is the trick, guys. So let's store the smallest element. समझे चच्चा, अब तुम्हारा काम बन जाएगा. DPI of J. Now I am changing the meaning of the state. Okay, let me do it. Undo. DP of IJ means the such that subsequence such that from index 1 to I XOR equal to J exists. XOR equal to J is existing, and the last element of this subsequence is stored in DPIJ. Guys, DPIJ means, try to understand. DPIJ का मतलब ये है कि you have found a subsequence from index 1 to I such that the XOR is J and the last element is stored in DPIJ. The last smallest possible element is stored in DPIJ. Okay, the last smallest possible element is stored in DPIJ. For example, I will explain you. So, guys, let's say you take this thing. Okay, now if someone tells you, tell me DP of 5 of 0. First thing, is it true or not? Is there a subsequence from 1 to 5 such that if you pick that subsequence, it is valid, all sorted, and its XOR is coming as 0? Yes, guys, there are two subsequence. First is 1 to 5. Then there is 1 to 3. Okay, first there is 1, 4, 5. So 1 is less than 4, less than 5, and 1 less than 2, less than 3. And also their bit count is valid. Okay, so the bit count of 1 is less than equal to 4, and bit count of XOR of 1 and 4, if you do, uh, if I do, yeah, it will also be less than equal to 5. So, and this is also valid. So in this case, guys, yes, this is also true, and this is also true. So first thing is, yes, there is a subsequence such that you pick it from number 1 to number 5, and the XOR is coming as 0. But what is the smallest possible last element? Smallest possible last element. One is 5, one is 3. So what will be the answer? 3. You always store the smallest possible एलिमेंट ऑफ द वैलिड सब्सीक्वेंस. इफ यू स्टोर द स्मॉलेस्ट पॉसिबल, तो क्या होगा, जब आप खुद को एनालाइज कर रहे हो तो आपको आराम से पता चल जाएगा क्या कोई ऐसा बंदा है जिसका जॉर ये है और लास्ट एलिमेंट ये है. और स्मॉल क्यों होना चाहिए? ताकि वो अपन से छोटा हो, समझे, तो चांसेस ज्यादा होंगे उसके अपन से छोटे होने के. So that's why we did this trick. For example, now why is XOR of 1, XOR 4, XOR 5 0? ये अपने घर पे करके देख लेना, ठीक है, नहीं तो मैं बता देता हूँ. 0 0 1 looks like this, 1 looks like this, 4 looks like this. So if you do the, and 5 looks like this, if you do the XOR, it will come as 0 0 0. Similarly, 1 looks like this, only consider first two bits. 2 looks like this, 3 looks like this. If you do the XOR, it will come as 0 0. So इनके XOR भी 0, ये सारे कंडीशन सेटिस्फाई कर रहे हैं. बट हम इसमें या तो 5 लिख सकते थे या तो 3 लिख सकते थे, बट मैंने 3 क्यों लिखा? आई एम willfully storing the smallest possible last element. Okay, smartly storing, smartly storing the smallest possible last element for valid subsequence from I to 1 to n, from I equal to 1 to n, such that its XOR is J. Now it will really help you. Okay, now. So if you go to the code, you will see, guys, see, I only created these two things. These basic things you will be able to. First, I am giving, assigning everything as 500. Okay. 500 can never be the answer. So I'm giving any value bigger than 100. Because the last element can be from 1 to 100 only, na guys. If it is 500, it's wrong. So you will be able to understand these things. Now I see dp1 of b1 is 1. This means the subsequence which starts at 1 ends at 1, and forcefully is willfully, like, we will have to include the first element. So what will be the smallest element? अब पहला include कर रहे हो तो पहला include होगा और और भी b of 1 ही होगा. Now guys, see only two loops. I is going from 2 to n and j, the XOR. So dpij should tell you, is there a subsequence from 1 to I such that the XOR is J? If there is, what is the smallest element coming at the end? So there are two options. Option 1, option 58. Okay. So first thing is, guys, don't do anything. Don't consider the I element. Ignore the I element. If there is a guy dpi minus 1j, if dpi minus 1j there is a guy less than equal to 100, that will be your answer. Simple. ये तो मैंने पहले भी सिखाया है. Don't consider the last element as the ith element. Okay, so this will be one option. Another option will be what, guys? First to calculate G. Another option will be if there is a guy from index 1 to I minus 1. Other option means you're including the ith element as the last element. I minus 1 और I को आपने separate कर लिया, ठीक है, ये देखो I minus 1 और I को separate कर लिया. If you're including the ith element as the current guy, then if there exists a subsequence from 1 to I minus 1 such that its XOR is G and its last element, and if its last element, if its last element is less than equal to, if its last element is less than equal to your current element, then your job is done. That's it. It's so easy, guys. It's so easy. So this is the another option. Yeah, I have created some special cases also. You guys will later on realize. Okay. So guys, here also I can see that one of the conditions is missing. Okay. And that very important condition is, let me fix this up. Let me fix this up. It's very important to fix. Our current element should be greater, na? So how can we miss this thing? Sorry for the video to be so long. Okay, guys, देखो, first option is clear. You don't include the last element. So if there is a subsequence from 1 to I minus 1 having XOR j, and it is having a valid last element, then yeah, that's only your answer, DPI minus 1j. But if you get a valid guy from I minus 1 to g such that it is valid coming less than equal to 100, its last element is less than equal to 100, and that g itself is less than equal to 128, and also the count of g is less than equal to count of b of I. And one more thing, guys, one more thing. uh, that thing should be that dpi minus 1g, whatever is the smallest element, it should be strictly less than b of I. This thing we were not considering. Okay. Okay, this thing we were not considering. Okay, I it's so nice that it's coming in front of everyone. So guys, see, there are only three options. First thing is that the previous subsequence which you're taking from 1 to I minus 1, its XOR should be G. The last element is what, DPI minus 1G. It should be strictly less than B of I. Also, no one in this world is going to explain you like this at the current moment. Also, the DPI minus 1G, the value which is coming, it should be less than equal to 100. मतलब है एक valid element. अगर 500 है मतलब fake है. 500 तो मैंने पहले ही initialize कर रखा था. If all these are true, and the count of G is less than equal to count of B of I, then your job is done. And similarly, guys, there is one extra case. This I leave up to the reader to explain. Okay. Okay. So whoever is reading, they should understand why Kumar K made this case. Special case for DPI minus 1G0. Because if the last element cannot be never be zero, na, but sometimes you might require. So DPI minus 1G. Okay. If G is zero, okay, this case is already covered. Okay, no worries. If the previous stuff is zero, and this, even if this guy is coming the greater than 100, then also it's valid. Okay. Okay. Then now if you try to do nicely, you take the minimum of both the options and DPIJ is filled. Now guys, it's simple. Iterate from 0 to 128, because 0 can also be there. DPN will tell you, is there a subsequence from 1 to n such that the XOR is coming as VL. If it is there, then the value will be less than equal to 100. If it is less than equal to 100, yes, you found it out. So I'm printing the values and I'm increasing the count, and that's it, I got the answer. So 5 1 2 3 4 5, the correct C++ codes we have. The Java Python codes also I will update and upload very soon. Okay guys, you don't need to worry. Now the time complexity will be very small here, because here I am only using two loops, I and j. N into 100, n into 100 will be the time complexity, n into 100 like 130 will be the space complexity. Here also two loops. See, we have, this was the hardest dynamic programming or problem media.net ever asked. I've taught this also to my students. Guys, go and become successful, get the package, and then send me the message that you got selected. We'll we'll celebrate on LinkedIn. So guys, similarly, I will update the Java and Python codes. Okay, for now I'm closing the session. Guys, always remember, the all the time that is based in overthinking, depression, sadness, shockwave should go in your brain. That all of this time, if I put it in my improvement, self-working, DSA, full stack development, learning about LinkedIn, resume, off-campus training, taking guidance, advice from good people, Kumar K or anyone, whatever you want. If you do the hard work in your life, then the results are most probably guaranteed. So please put all your time in working. Don't think of the problem, think of the solution, and your life will be easy after that. So, in the name of God, Ram Ram. The end.